Good afternoon. My name is Shobhit Bhattacharjee, roll number meb22043, and I am here to explain my end semester problem for the CAE examination, which is simulate mixed convection with in a vertical regular cavity using ansys fluent. Here I am going to begin. First, I am opening the fluent, and then opening the geometry, where I am opening the design modeler. And now that the design modeler is open, I am clicking the XY plane and creating a rectangle. I am going to sketching and then selecting a rectangle where I am going to draw a rectangle from the origin with dimensions as follows. Dimensions. The length I am giving as 10 meter and the height I will be giving as 20 meters. Now generate. After generating, I am going to select the body and make the surface into fluid surface, into the sketch and apply, generating. Here we have a surface, and now I'm going to change it from solid to fluid since we are doing a fluid problem. Now that everything is done, now I'm going to name all the sides, selecting the edge, name selection, and now I'm going to name all the four sides. This is top, generate, and then I'm going to select the bottom side and keep naming all the edges. This is the bottom side, bottom, generate, and selecting the left side, now changing screen to left, generate, and then the final edge I am going to name it right. And selecting the surface, I am going to name it surface, going into the name selection and surface, generate, and we are done with the design modeler. Now I'm going to close this and open the mesh. Now selecting the surface, I'm going to mesh. Here are all the named places and generate a mesh. going to change the sizing of the mesh element, inserting the sizing, changing the type from element to number of divisions, and giving the number of division 20 for this side. Generate, and then selecting the other edge and doing the same thing. Insert element size to number of divisions. Here I am going to give the number of divisions as 40. Generate, and let's adjust the sizing, growth rate to 1. Generate. Now we have generated a mesh. Now meshing is done. Now I'm going to close the meshing window. Now opening the, now I'm going to update it. Okay. Now it's updated. Now let me open the setup here, 2D, and start. Going to the material, selecting the fluid as air. It's already set as air. Setting the boundary conditions for the bottom side. It's a moving, I'm going to set it as moving wall with the velocity of 0. Let's say 0.001. In the Y direction, applying it. Now editing the left side as well. The corner part. There was an issue. Now I have turned on the energy equation and also set the viscous to k omega, and in general I have also set the gravity in y direction minus 9.81 meter per second square. Now adding the boundary conditions. The bottom one is already done. We are reading the left side now. The thermal heat flux, let's say 500. Applying it. Similarly, editing the right side as well. Thermal going to temperature, and the temperature is set as 300 Kelvin. Applying it. Now for the top side, here the gauge pressure is 0. It's already set to 300 Kelvin, and it is already selected as pressure outlet. Applying it. And now for the bottom side, in the y direction, the speed is already given. The boundary conditions are stated, and now going into the solutions methods. The pressure velocity is already set as coupled. Now these quantities are also properly set already. And now initializing. Hybrid initializing done, and now I'm going to run the calculation. Iterations, let's say 200. Now calculating. Calculation is complete. Now we're going to close this and open the results. Open the edit. Now inserting a contour. For we have to generate a surface first, plane first. Inserting plane. Let's name it plane 1. Apply. Now we have our plane. Now we are going to contour the plane. Contour 1. Let's set it for the plane, and the variable, let's check for temperature. Applying. Now here you can see we have generated the required answer. Here is the temperature variation in the following thing. Now let's check for mass as well. finally, let's also check for exit velocity. Okay, so with this we can say that uh, we have successfully stated how the temperature varies and how the Rayleigh number also affects increasing Rayleigh numbers intensifies convection effects, enhancing heat transfer efficiency but reducing temperature uniformly. For engineering applications, optimizing Rayleigh number can balance efficient heat removal with acceptable thermal gradient depending on the system.